Hello, today I will be showing you how to get the quadratic equation for a catapult. First, you need the max distance, which is how far it is from when the gumball lands to the catapult's release point. In this video, I will be using my own data. So I got 177 inches, and I will demonstrate that right now. So I'm going to load my catapult. Give me a second. And then I'm going to fire. I'm going to do that again. I'm going to just do it over and over until I get a consistent point. Third time's the charm. Where is this? Yeah, so it's all picking up out over here. So now I just need to measure the distance. Oh, where's my measuring tape? Over here. So I'm going to measure from the release point, which is over here, all the way to where it landed. So I'm going to go all the way back, and let me see, yeah, it's about 177 inches. Now let me erase this. Now you have to consider the fact that 177 inches isn't the whole thing, because you get this portion, but you need this extra portion back here to complete the arc. That extra portion is the same thing as this part over here because it mirrors itself. To get that extra portion, you have to set your catapult away from the wall. So here's the catapult, and you have to find the height of its release point. So mine was about 5 inches. So I would put it away from the wall, so when it came down, it would hit 5 inches. And I'm going to try that. I'm going to move it and try to hit that at a height of about 5 inches. I need to move it a lot closer. Did I forget something? Wait, where's my thing? Where's my stick? Hey, where's my stick? Sorry, I had to get something. So, put it away from the wall. We go load it. Fire. I'm going to put like a post-it on the walls about where it hit. And let's see if it can hit that height again. Where's my gumball? Okay. Wait, get out of the way, you might get hit. So it's about over here. That's not 5 inches. So I'm going to have to lower that. And also at the same time, I'm going to have to move the catapult back. That was kind of close. Okay, so that's about it. Now I'm going to measure that distance from about here to here. This is so it's about 174 inches. Can you see it? 174 inches. Wait. 174. So now I have that extra distance. So I have this extra distance back here because you would have to take the max distance minus what you just got. And I got 3. So I'm going to add 3 back onto the max distance because I would know that this is 3. So 3 plus 177, I get 180. And now you finally have the roots. That took long. Now you have the roots, which are 0, 0, the starting point. And for me it was 180, 0, which is the ending point. Now you need the vertex. To get the vertex, take half of the longer root, which is 90, and put your catapult that many inches away from the wall. And now I'm going to show you that. Okay, one-way gumball. Okay, let me get the, see, this is 90. 90. So I would set the catapult that many inches away from the wall. So I'm going to use it. So I'm going to get closer. It's going to be like this. I have to put the catapult to at least point it out that distance. And now let me see how high it can go. Give me a second. So I hit about this height here. And then the gumball right away. So now I'll have to confirm that height. Oh shoot, accident. So it's a little higher. So about up here. Now let me try for a third time. Yeah, that's about the height. Now I need to find, now I need to measure this. So that's like, right, about 40. You get that? Okay. So that's basically all we needed. So now you have the roots, and then the vertex, which was half of this, 90, and then the height, which was 40. Now all I need to do is substitute this into like an equation, and I can easily get the quadratic equation. So the equation's f of y equals a times x minus the first root and x minus the second root. X and y are the coordinates for your vertex, and the roots are, well, your roots. You would have everything but a, so you have to solve for a. So y was 40 equals a, x minus the first root, and x was 90, and x minus the second root. Now solve for a. 40 equals a times 90 times negative 90. 40 equals a times negative 8,100. A equals negative 2 over 405. So now you substitute that back into that same equation. Change the y into an f of x. So f of x equals negative 2 over 405. Leave the x as is, but substitute the roots. X minus 0, x minus 180. F of x equals negative 2 times over 405 times x squared minus 180x. F of x equals negative 2 over 405 x squared plus 8 over 9x. You have the quadratic equation, but now all you have to do is graph that. Now I'm just going to show you the graph, but I'm not going to do all the work. That's going to take too much time. I already got it beforehand. So I'm going to use 30, 60, 90. I'm going to use 30, 60, 90, 120, 150, 180, just for the sake of space. So at 30, the height, the y would be 22.2, so it's about over here, 22.2. At 60 is about 35.6, 5.6. At 90 it's about 40, which is the vertex. At 120 it's about 35.6. You see it reflects over from this side. And then, of course, this is going to be 22.2, and this is going to be back to 0. Now graph that, and you have the graph and the quadratic equation.